Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to start the next organic chapter, that is alcohols, phenols and ethers. Okay, so I hope you are you have been studying this series, you have completed haloalkanes and haloarenes, and yes, today we are in the second chapter, and in this lesson we will be discussing about the classification of these compounds, nomenclature and their structure. Okay, so one more request, please join our WhatsApp channel. It is very important so that you can get all these notes, the question papers, solutions, everything in our WhatsApp channel. So please do not forget to join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. Okay, so you can just go there, click on the link and join the channel. Okay, so now without any further delay, let's get started. I want everyone to sit with a notebook and a pen and note down all the important details here. Okay, and we are also going to practice a lot of questions today. Okay, so now I'll be telling you how are we exactly going to cover this chapter. Okay, so in this chapter we'll be having 4 parts. Okay, so in part 1, that is today's lecture, will be covering classification, nomenclature and the structure. Okay, this is very important, nomenclature, very important. We'll see this. Then in the second part we'll be doing preparation of alcohols, preparation of phenols and then physical properties. Okay, and in then part 3 we'll be studying chemical reactions of alcohols, then we'll be studying chemical reactions of phenols, and in the part 4 we'll be doing some commercial alcohols and then complete ethers. Okay, so in this way we have divided this chapter. Clear? So I hope today's lecture what we are going to do is clear: classification, nomenclature and structure. Okay, so if you see year wise weightage, so every year you can expect 2 to 3 questions from this chapter. Okay, very high weightage topic, 3 questions are there. You can easily expect 2 to 3 questions from this chapter. Okay, next, coming to today's lecture, as I told you, part 1, we are going to discuss classification, nomenclature and the structure. Okay, fine. Now let us discuss about classification. So classification we have done majorly. So now first we are talking about classification of alcohols and phenols. Okay, ethers will come later. Now see, first classification is based on the number of OH bond present. Okay, now how many OH is present in one particular compound. Now why OH? Because for alcohol, the functional group alcohol, okay, alcohol is represented by OH group, right? So how many OH groups are there? On the basis of that we can do classification. Second is on the basis of hybridization of sp3COH bond. So here we have alkyl alcohols, allylic and then benzylic alcohols. Okay, and next on the basis of sp2COH bond, here we have vinylic alcohol and then we have phenols. Okay, so I'll explain all this with example, it will be very clear. Okay, so first coming to number of OH group. So if you can see here, there is only one OH group, so we call it monohydric. If we have 2 OH group, we call it dihydric. If we have 3 OH group, we call it trihydric. Okay, this is very simple. 1 OH group mono, 2 di, 3 OH group trihydric. Okay, the first classification. Second is on the basis of the sp3COH bond. Okay, now see, sp3COH bond means this carbon, okay, which contains the OH group. If that is attached to only one another carbon, then it is called primary alcohol. Okay, see what I am explaining, carbon containing the OH group is attached to only one carbon here. Okay, then it is called primary alcohol. Carbon which contains the OH group is attached to 2 another carbon here, that is called secondary alcohols. Next, the carbon which contains the OH group is attached to 3 other carbons, then we call it as tertiary alcohols. Okay, carbon containing the OH group is attached to 1 carbon, primary. Carbon containing the OH group attached to 2 carbons, secondary. Carbon containing the OH attached to 3 carbons is called as tertiary. Now this is the first classification. Next, what is allylic alcohols? See, in allylic alcohols, carbon containing the OH group, okay, carbon containing the OH group should be attached to a sp2 carbon. Okay, carbon containing the OH group, carbon containing the OH group should be attached to an sp2 carbon. Okay. Now, in this, if you see this carbon is attached to only one carbon, so it is primary. Now, here if you can see the carbon containing the OH group, it is attached to an sp2 carbon and in total it is attached to 2 carbons. So, it is secondary and it is also allylic, right? It is secondary and it is also allylic. And next one, if you see carbon containing the OH group is attached to one sp2 carbon and also 2 other carbons, right? So, it is tertiary and it is allylic. Okay. So, here if you see carbon containing the OH group first should be attached to an sp2 carbon. sp2 carbon means carbon having double bond. Now, this one if it is attached to only one carbon, it is called primary. Now, like allylic and primary. Next, it is attached to this one sp2 carbon also, and that in total it is attached to 2 carbons, so secondary. Here it is attached to one sp2 carbon and in total it is attached to 3 carbons, so it is tertiary. Okay. Next, coming to benzylic alcohol. So, if you see carbon containing the OH group should be attached to the benzene ring, then we call it benzylic. Okay. Here what happens, carbon containing the OH group is attached to the benzene ring and it is also attached to another carbon. So, I can say that this carbon is attached to 2 carbons, so it is definitely secondary. Here carbon containing the OH group is attached to the benzene ring and this carbon is connected to in total 3 carbons, right, 1, 2 and 3. So, that is called tertiary. Okay. So, next coming to sp2 carbon. So, in sp2 carbon what we have, vinylic alcohols, means carbon which is attached, which contains the OH group is also having a double bond. Okay, vinylic means we have already seen it in the haloalkanes group. So, carbon which contains the OH group is having the double bond. Carbon containing the OH group is attached to the double bond. Clear? That is called vinylic. Next, phenols, you can see in phenols also we have on the basis of the number of hydroxyl group, one OH is attached, that is called monohydric. Okay. Now, here you also see one OH, so it is monohydric. Here you see 2 OH, so it is dihydric. Here you can see 3 OH, so it is trihydric, right. So, in this way we can classify the phenols based on the number of OH group present. Next, coming to ether. So, under ether we have 2 types again, symmetrical ethers and asymmetrical ethers. Now, what is ether functional group? Ether functional group is ROR, right. Now, if both these groups present on the side of the oxygen are same, then we call it symmetrical ethers. For example, you can see C2H5, C2H5, right. Now, coming to asymmetrical ethers, if this R and R group, one is R group, another is R dash, different groups, then we call it asymmetrical ethers. Like for example, you can see here this is C2H5, here it is CH3, here it is C2H5, here it is C6H5, right. So, seeing this is an asymmetrical ether. Clear? So, yes, this is all about the classification. Okay. Now, we have to segregate them as primary, secondary and tertiary. Okay. Let us check this. First one, carbon containing the OH group is attached directly to only one carbon, right. So, this is primary. Many of you might do a mistake here by writing tertiary, but remember carbon containing the OH group, okay, carbon containing the OH group is attached to directly one carbon. So, it is primary. Here if you see, this is carbon containing the OH group, but again yes, this is connected to only one carbon directly. So, this is also primary, but is it a normal primary? No, it is allylic primary. Okay. Next, if you see here, carbon containing the OH group is attached to one carbon. So, yes, this is also primary. Next, carbon, okay, this one you see, carbon containing the OH group is attached to 2 carbons, this carbon and this carbon, right. So, this is secondary. Next, if you see here, carbon containing the OH group, this carbon is attached to 2 carbons, right. So, again this is secondary. Here if you see, carbon containing the OH group is attached to 3 carbons, right, this one and this one. So, this is a tertiary group. Clear? Very simple. Just you have to see the carbon which contains the OH group, that is attached to how many carbons. Okay. Fine. Let us now move towards the nomenclature. So, first we will see nomenclature of alcohols. So, for alcohols the name the name, the suffix that is used is OL group, right? So you can see here common name and the IUPAC name. So very simple, you have one, suppose CH3OH, for one carbon we use meth, so it is methanol, and common name is methyl alcohol. Here it is propanol, common name is N-propyl alcohol. This structure you should remember, isopropyl alcohol, that is a propane 2OL. Normal butyl alcohol, that is N-butyl alcohol, butane 1OL, right? So these are all here. This is very, very important. Isobutyl alcohol structure you should know, okay? Then tertiary butyl alcohol structure you must remember, okay? Next, coming to next, if you see 3 carbons are there and all the 3 carbons are having one OH group, then we call it, common name is glycerol, okay? And similarly, if you have 2 carbons like this and OH group is attached, then we call it ethylene glycol, okay? These 2 common names are very, very important, you must remember it, okay? Fine. Next, we will go to the nomenclature of phenols. Here it is very important to remember the common names, okay, because in options you get the questions with common name also, okay? So you can see here, this is phenol. With phenol at ortho position, if it is methyl group is there, we call it orthocresol, okay, or 2-methyl phenol. Now for, if there is CH3 at the meta position, we call it metacresol. Similarly, we have paracresol, okay, 3-methyl phenol and 4-methyl phenol respectively. Next, if you have 2 OH groups, okay, then we call it catechol, okay. If there 1,2 position, 2 OH groups are there, we call it catechol. 1,3 position, then we call it resorcinol, and then we have 1,4 position quinol, okay. So catechol, resorcinol and quinol, clear? Fine. Next, coming to the nomenclature of ethers. So ethers, if you see what is the format followed for their name, alkoxy alkane, okay. So one part is written as alkoxy, another part is written as alkane. So here if you see, we have both sides CH3, so one side is methoxy, another side is methane. Here again ethane, ethyl group, so ethoxy, ethane. Now here you see one side it is methyl group, one side it is propyl group. In that case what will happen, this one will be taken as the parent chain. So I can say first carbon methoxy group is attached, so 1-methoxy propane, okay. Similarly here you can see it is 1-methoxy benzene, okay. Next you can see benzene ring is there, and then there is a ethoxy group attached, so we can have ethoxy benzene, okay. Next you can see here we have a long chain of 7 carbons, so we can write phenoxy, then heptane, right. Next you can see this one 1, 2 and 3, so 2-methoxy propane, right. Next you can have here, if you see 1, 2, 3, 4, 5 carbon we have, right, and in this there is 6 carbon, so 6 carbon will be taken as the main chain, okay. So we will have here 1, 2, 3, right, so 3-methyl butoxy benzene, okay. So like this you can see the nomenclature of ethers. Just you have to check alkoxy alkane. Alkane should be the one which has more number of carbons, okay. What I am saying, alkanes will be the one which should have more carbons, okay. Fine. Now let us try these questions. We have to write the nomenclature for them. First one, see, you can find the OH group here, right. So from there we need to start getting the longest carbon chain. So if I write 1, 2, then we can go this side 3, 4 and 5, right. So I can say that second carbon there is a substituent, third carbon there is a substituent, right. So second carbon, if I number it again, so 1, 2, okay. So now we can write it as like this. See, first I'll write 2, on the second position I have this methyl ethyl, okay. 2, on the 2 position 1 methyl ethyl group. Then third carbon I have chloromethyl. Okay, and then we have pentane, 5-pentane 1-OL, or I can just simply write pentanol. Clear? Next one. Next one again we can see there is 2 OH groups present. Okay, we can find the longest carbon chain here. So I can write 1, 2, 3, 4 and 5, right? So we have on the second, 1, 2, 3, 4, 5 and 6, right? Yeah. So we can have, you can see third carbon OH group is present and first carbon OH group is present. So we can write it like this. First methyl groups are present on second and fifth carbon, right? So I can write 2,5-dimethyl. Okay, then hexane. Okay, first and 1,3-diol, right? Why diol is coming? Because we have 2 OH groups. Okay, next third one, if you see, this is very simple. We can write 3-bromo, right? Cyclohexanol. Okay, next coming to fourth one. Fourth one, if we see, we can just number it in such a way that alcohols get the least number. So I'll number it in this way. So I can write hex 1En 3OL. Okay, next one coming. Okay, next one again we need to do numbering. We should give least priority number to alcohol, 1, 2, 3 and then 4, right? So we can write 2-bromo 3-methyl, 2-bromo, alphabetical order, right? The substituent should be written alphabetically order. So 2-bromo 3-methyl but 2En OL, right? Ending should be again with OL. Clear? Okay. So yes, like this we can write the IUPAC names of these compounds. Fine. Let us go to understand the structure now. See, so what happens in alcohols? The oxygen of the OH group is attached to the carbon by a sigma bond formed by the overlapping of sp3 hybridized orbitals of carbon with a sp3 hybridized orbital of oxygen. So now you can see that in COH bond. Okay, so there is one sp3 orbital of carbon and sp3 orbital of oxygen which has undergone overlapping to give you this bond. Okay, so the bond angle here is between 108.9. In phenol, this bond angle is between 109. Okay, and here it is around 141. Okay, now this is because of these bulky groups present. Sorry, this angle is 101.7. So because of these bulky groups present, what happens? The bulky groups move because of repulsion. They move far away from each other and this bond angle slightly increases. Okay, fine. Okay, so now we will do some questions. Okay, let us see how much we have learnt today. According to the IUPAC, what is the suffix used for alcohols? So just now we have discussed it is OL. Okay, in the naming of alcohols we use the suffix OL. Next, common name of butane 2OL. So if you draw the structure, this is butane 2OL. So it is secondary butyl alcohol because this is a secondary group, right? Next, glycerol is a glycerol structure, if you remember, right? This is glycerol structure. I told you this is very, very important structure. So it is a trihydric alcohol. Okay. Next, which of the following is not a polyhydric alcohol? So if you see glycols, polyhydric means more than one. So these all are having more than one. Cyclohexanol has only like this structure. one OH group, right? So yes, option number A here. Next, which of the following phenols is not dihydric? Okay, so if you remember catechol, resorcinol and quinol, these all are 1, 2, 1, 3, 1, 4. 1, 2, 1, 3 and 1, 4 structures. Paracresol structure, if you remember, paracresol was like this, right? So it has only one OH group. So that is why option number A. Okay. So yes, now this question is a homework for you. Okay, you need to try this question, solve this question, and do not forget to comment down the answer. Okay. So yes students, so that was the part 1 of the alcohols, phenols and ethers, a very small chapter, a very small topic this one, but yes, very important. Nomenclatures are very important here. So yes, just watch this video, practice some more questions on nomenclature, and if you have any doubt in any of these concepts, do not forget to comment down. Okay, I'll definitely address it. So stay tuned for next class, where we are going to discuss the most important topic, that is preparation of alcohols and preparation of phenols. Okay, thank you, and please do not forget to subscribe the channel, join the WhatsApp channel, and keep working hard for your KCET 2025 examination.